the 19th century, buildings constructed around the United States, primarily in larger urban hubs like Chicago and New York and Detroit, began to set new, modern construction height records, weighing in at 10 stories and higher. These upwardly evolving blueprints were the consequence of new technologies and materials, among them the advent of steel framing that allowed load-bearing outer walls to be piled higher than was conventionally possible with older building methods. And a load-bearing outer wall basically means the external skin of the building, the walls, played a role in holding the building up. It's a structural, not just a decorative element. Curtain walls, which are decorative but also help create the internal environmental envelope of a building, but which don't hold anything up, they're not load-bearing, were enabled by more advanced and sturdy steel framing setups and arrangements, and because of their non-load-bearing nature, could be constructed of lighter weight materials. They have to hold themselves up and prevent the air and people inside the building from escaping or falling out. But otherwise, they just have to look pretty, or at least not ugly, and allow in light and things of that nature. And that's a task easily managed by a wider array of materials, including glass and various sorts of insulating substances. The steel frame that enabled these curtain walls is what you see in modern high-rise buildings when they're under construction. Central skeletons of metal that are eventually filled in with livable components, like walls and floors, made of metal and wood and concrete and plaster, but which are initially just steel bars arranged in such a way that you can build up and up and up. The steel itself, relatively lightweight, but importantly, also very resilient and flexible and resistant to both environmental wear and tear and shocks from things like earthquakes and high winds. They don't rust, they are more likely to bend than break, and they're strong and sturdy enough to hold up a lot of building. So the introduction of new steel alloys, which further empowered this fundamental building material, is part of what allowed for the construction of buildings that are not just high-rises in the sense that ancient Rome was full of high-rise buildings that climbed up to 10 or more stories before being capped by safety considerations and a law that limited such buildings to around 82 feet in height. That limit applied with mixed results for safety reasons and to maintain the view for wealthier Roman residents who often lived in the lower stories amongst all the shops, but also for the sake of the poorer residents who had to live higher up where it was colder and a lot less accessible. A potentially large number of stairs being the only way to get home at the end of each day. Part of why many early skyscrapers arrived in U.S. cities first was that the States was seeing a boom in manufacturing capacity, raw materials production, and the divvying out of patents to inventors of clever things who were arriving in the country from overseas on a daily basis. One such invention was the load-bearing structural frame, which I mentioned earlier, the internal steel skeleton of a building that allows the outer walls to be curtain walls, rather than bearing loads themselves. And another was water pump systems that allowed running water for consumption, but also for showering and toilets and fire safety systems to be pumped all the way to the upper floors of these buildings. Something that was previously not possible and either neglected entirely or handled with less structural and more expensive, tedious manual replacements. The introduction of elevators in the mid-19th century, in their earliest form, allowed folks to get to the top floors of these increasingly tall buildings without wearing themselves out, and allowed folks to get to safety if something went weird with their early electrical or plumbing systems. Skyscrapers were also, after their initial introduction, which involved a lot of refurbishing of existing buildings to make them taller, and what later became thought of as wasteful excesses, primarily meant for decoration, or the consequence of a lack of experience with these new tools and technologies and designs by architects and builders at the time. Skyscrapers also became more economical and efficient than their traditional counterparts. Skyscrapers allowed for the sharing of resources, including, importantly, the HVAC systems that enabled the heating and cooling of upper and lower floors, which is part of what makes a consistent temperature and humidity level possible, no matter how high up you are. It enabled the cramming of more people and offices and storage into less space, and the utilization of vertical space rather than horizontal, which made these buildings especially appropriate and desirable in dense urban areas, which is where they took off in a big way, first in the US, but then very rapidly, especially after the elevator was introduced, in other countries as well. What I'd like to talk about today is the introduction of a new technology predicated on a very old technology that's taking the high-rise and skyscraper world by storm. You're listening to Let's Know Things. I'm Colin Wright. Let's Know Things is an independent, listener-supported show. If you're finding some value in what I'm doing here, consider becoming a supporter. One of the simplest ways to do that is to become a patron at patreon.com/letsknowthings. You can also become a member at understandery.com. But you can find a complete list of both monetary and non-monetary ways to support this show at letsknowthings.com/support. A great big thanks to everybody who's already helping to support this show, and thank you in advance if you're considering doing so in the future. All right, let's get back to the show. The article I'd like to start with today comes from the Wall Street Journal, and it's entitled, "Wooden Skyscrapers Are on the Rise." This piece is centered around a product, a building material, called mass timber, which is short for massive timber, focusing in part on several new buildings that have been or are being constructed out of this material. One of which is 20 stories high and was built in Sweden. The construction was completed last year in 2021. This building sprawls 323,000 square feet, and in addition to a high-rise hotel, it also houses a performing arts center and theater, a museum, a gallery, and a library. Looking at photos of this building, the space looks striking, and to my eyes at least, beautiful. And that's part of the appeal of this type of material. It lends the interior spaces a well-textured, raw wood look, but with the construction consideration benefits of building with steel. Mass timber, sometimes called engineered wood, is a term that encompasses a bunch of different approaches, all of which involve imbuing wood with new properties that allow it to be leveraged in a wider range of use cases. For this Swedish building, mass timber was created by producing raw wood building materials in the usual way, then laminating, combining, and pressing them so that the wood grain in one board is cross-hatched with grain from an accompanying board, and then another and another and another is added, so that all of these boards are glued and compressed until they are practically one board that is multi-grained and thicker. And that final board has similar properties to steel in terms of flexibility, strength, and other important attributes of that kind. You can also refine these wood products to give them other properties, to make them more like concrete rather than steel, for instance. They can be used more decoratively as well, serving as curtain walls, hung from a structural mass timber frame, replicating most components of a traditional skyscraper, using all wood products, each treated in different ways, rather than using steel and a bunch of concrete. This building style has been on the rise in Scandinavian countries, in part because its use replicates a popular, traditional, local building aesthetic that required a lot of local timber. But it's becoming more common elsewhere as well, as the benefits, in terms of eco-friendliness, cost-effectiveness, novelty, efficiency, and style, trickle out into the wider architectural world. In the US, for instance, the number of multi-story mass timber buildings increased by 50% from July 2020 to December 2021, up to a little more than 1,300 such structures by the beginning of 2022. Some of these buildings are private residences, but the ones that tend to make the most waves and get the most press are larger buildings, like an 8-story office building in Virginia, a new Google building in California, and a new residential/storefront building with 25 stories in total here in my current hometown of Milwaukee, Wisconsin. The International Building Code has rules on the books that allow for regulation mass timber buildings of up to 18 stories. And that building here in Milwaukee, with its 25 stories, was able to get an exception to those standards because they submitted their plans ahead of time and showed that what they had in mind would be just as, if not more, safe than a similarly sized building constructed from more conventional materials. But architects around the world have been taking to this material with enthusiasm, and as a consequence, there are quite a few massive skyscrapers planned, including an 80-story building in London and a 70-story building in Tokyo, both of which are only at the planning and proposal stages. But the companies and designers of said buildings are banging the drum pretty hard to make these materials and building styles more common. Part of that enthusiasm is tied to the novelty of this approach, especially at a moment in which environmentalism is so popular. Anyone who can show up with a proposal that stands out and seems to align both the builder and the customer with even a hint of greenness will tend to have an advantage over folks proposing more of the same, the only variation and distinctiveness being in their aesthetic flourishes. There's evidence, though, that such buildings can also be cheaper than their steel and glass alternatives, especially if there's a source of timber and a manufacturing hub for processing that timber nearby, which again is part of why this style has become so popular so quickly in some Scandinavian countries, where such timber resources and adjacency to them is relatively common. There are also chronological benefits, because you can replicate the consistency and stability of concrete using this approach, and because the materials are lighter than the steel and concrete that would be traditionally required higher up on the building. So there's no concrete pouring and concrete drying period to worry about for either the foundation or for each floor, which typically takes a very long time and requires a large number of workers to manage. Something like 40 for a building the size of the one that's being built in Milwaukee. But because they used mass timber for many of these foundational elements, they were able to install them with only 10 workers. Likewise, these materials tend to be lighter and thus easier and cheaper to transport, simpler to handle, and they don't require as many resources to produce. The manufacturing of steel and concrete are actually two of the biggest carbon dioxide emitters globally, accounting for something like 11% of all greenhouse gas emissions, which is part of why the construction industry overall is so massively polluting and ripe for new regulation in the coming years. This type of building might help this industry wean themselves off that CO2 addiction while also revealing new efficiencies and cost reductions along the way. There's also a latent planning and preparation related benefit to working with mass timber as it's produced today. Generally, the timber is laminated and pressed into specific shapes. So you can do typical 2x4s and other common building elements of that kind, but often these pieces are produced in their final shape, which allows each piece to be optimally stable for its intended use case, while also allowing construction workers to sort of just pop them together on site, each piece having its proper place in the design from the get-go. Some construction companies that work with this material have compared it to working with Legos or Lincoln Logs. It's just a whole lot easier to put these things together compared to working with other standardized sized building materials, which often have to be reworked as they're handled, and thus mass timber construction enjoys some of the same benefits of putting together prefabricated buildings. A lot of the effort is done off-site in spaces optimized for production, rather than last minute at the building site. Some of the common concerns associated with this building material would seem to be unwarranted, as in the case of fire, mass timber doesn't burn like normal wood. The surface can char, but the planks and components themselves behave more like steel in that regard. They are very fire resistant. Likewise, there's evidence that mass timber could allow for larger and taller buildings eventually, as the material is a whole lot lighter, requires a lot less foundational reinforcement, and consequently could eventually allow for the construction of taller buildings than we can make today with a comparably smaller ground-level footprint. And the final building could be more resilient, especially to high winds and earthquakes, which is the opposite of some concerns which worry that there might be a cap on what this type of building material could allow in terms of height. There are some probably warranted concerns from environmental groups, though, because although the carbon footprint of such buildings seems to be a lot lower than comparable conventionally built buildings, and result in a lot less waste as well, there are worries that if popularized, mass timber construction could incentivize the culling of old-growth forests, which are carbon sinks. The wood itself sequesters CO2 even after it's cut, which is a potential benefit, but the ecosystems they leave behind when cut down could emit a lot more CO2 than is stored in this way. And cutting down too many trees could also trigger ecological issues like more soil erosion and the devastation of local species, because this would essentially obliterate their ecosystem. When harvested thoughtfully, then, tucking away CO2 in timber buildings could be a good thing, but if done over enthusiastically and unintentionally, it could lead to a lot of ecosystem destruction and other unintended negative consequences. Another negative criticism is that we don't know the long-term reliability of these materials, which is fair. Some early versions of these construction materials eventually cracked and failed, and though they've since been replaced with newer versions of the same, so far successfully, only time will tell with any new material. Of course, some of these concerns are being promoted by companies and lobbying groups connected to the steel and concrete industries. And in fact, the Build with Strength Coalition, which has fought tooth and claw against allowing mass timber into the aforementioned International Building Code, and which spreads a lot of literature about the potential unsafeness of wooden buildings in general, is sponsored by the concrete industry. So it's actually kind of a wonder that mass timber made it into the code at all, even if it is currently hobbled by that 18-story cap on building height for most designs and locations. Many of the near-future buildings using this material will likely use a combination of concrete, steel, and mass timber, despite the hype, warranted or not, about this building approach. The theory is that this makes such buildings less like statement pieces and into quieter, more practical applications of the materials, often using the more conventional stuff down low at the foundation, and then building up with the cheaper, lighter, more efficient, and in some ways more effective mass timber. This doesn't provide all the same benefits of a pure mass timber building, of course, but it does help demonstrate the benefits of using it, and might make it more common and accepted faster than a 100% pure shift over to mass timber by some, and a strict adherence to exclusively traditional norms by others. It may also give those traditional building materials industries a chance to themselves invest in this competitor, which in turn could incentivize them to invest in it further and push it into the mainstream, rather than struggling against it as being antagonistic to their financial well-being and maybe eventually killing their businesses. However that economic scuffle plays out, there are a whole lot of buildings planned globally using this material, and the 25-story construction in Milwaukee, which is currently scheduled to be completed in August of 2022, is unlikely to be the tallest in the region for very long. That said, part of what will determine how long it holds that title are pandemic-era supply chain snarls that have made harvesting, producing, and shipping timber supplies an expensive undertaking for about 2 years now. So while this approach will generally, if things swing back to a less inflated norm at some point, be less expensive than traditional building approaches in most places around the world, some of those currently proposed buildings may be put off for a few years or longer until the price tag associated with lumber of the mass timber variety and otherwise drops substantially. If you're enjoying Let's Know Things, consider becoming a supporter. One of the simplest ways to do that is to become a patron at patreon.com/letsknowthings. You can also support this and all of my projects at understandery.com. But also quite helpful is leaving a quick review wherever you get your podcasts. A great big thanks to everybody who's already helping to support this show in some way, shape, or form. And thank you in advance if you're considering doing so in the future. The book I'd like to recommend today is called Swamplands, Tundra Beavers, Quaking Bogs, and the Improbable World of Peat by Edward Strusik. This is the type of nonfiction book that digs deep into a topic that you wouldn't necessarily think to explore. Had I not seen this on a digital shelf somewhere, I wouldn't have thought to go find a book about swamps and bogs and peat. But I'm glad I picked it up. It's a very interesting read, it's well researched, and it's the sort of thing that fills in what will be, for most of us, I suspect, a great big gaping void in our knowledge and understanding about a facet of ecology and the environment and the natural world in general. Now, if any of that sounds interesting to you, consider picking up a copy of Swamplands by Edward Strusick. You can find out more about me and my work at Colin.io. You can find the show notes and transcript for this and every episode of the podcast at letsknowthings.com. You can find a list of my other projects, including my other podcasts, at understandery.com, and feel free to reach out and say howdy on social media. I'm Colin Wright on Facebook, and at Colin is my name on most of the other ones. Thank you so very much for listening. I'm Colin Wright, and I'll talk to you again next week.